In this video, we're going to look at a couple of examples of how completing the square can be used to solve some problems. Our first one is going to involve a maximum revenue type of question. You'll see these a couple of times as we go through this unit. Let's assume that I run a skate business at an outdoor pond in the winter months because of my love of the sport. And it's just something on the side so that I can get others to love it too. I charge $12 for a pair of skate rentals, and I get 36 rentals per day on average for the first few weeks of this business. I learned that every time the price goes down by 50 cents, as I play with the price over the next couple of weeks, I'm able to, on average, rent out 2 additional pairs of skates. So what I want to know is, what's my maximum revenue? How many pairs of skates should I have in stock so I can make the most money based on these trends? So for a maximum revenue question, what we need to remember is that revenue is based on 2 things. It's based on the number of items. I'm going to leave this very general so we can use it for other type of problems like this too, times the cost per item. Okay? And we're trying to find the balance between these two for one going up and one going down so that this can be the biggest number possible. We have to build an equation from the information given in the question. So you may remember that as I read the question to you, I began with 36 pairs of skates, and I began at a cost of $12. And I'm just going to put the dollar sign in so that you can see where the numbers come from. What I played with then in this scenario is that the number of items would go up every time the cost goes down. So every time the cost goes down by 50 cents, and I could write it like this, I'm going to put an X with it because if I put an X, if X is 1, that would be 1 50-cent decrease. If X is 2, it would be 2 50-cent decreases, 3, and so on. So every time a 50-cent decrease occurs, the number of skate rentals goes up by 2, and 2 times the number of 50-cent decreases, you see. So I can put an X in both places. Now, because I'm trying to find the maximum amount of revenue, maximum would imply I'm trying to find the vertex. I can't get the vertex from the equation in this form. Our first step is going to be to FOIL this out because it kind of looks a little bit like intercept slash factored form. So when I multiply FOIL, 36 times 12 is 432. The outsides, half of 36 and making it negative would be negative 18x. On the inside, I would have 24x. And for the last terms, I would have half of 2, which is 1, but it's also negative. And I have x times x to give me x squared. Let's combine these like terms together. And in doing so, we'll get 6x. And what I'm going to do at this point is I'm going to rearrange the terms so that they are in decreasing power of x. So starting with the highest power, which is the x squared term, then the x to the first term, and then if you'd like to think of it, x to the 0 or no x term there. So now we've got it in standard form. We learned in the video previous to this that we can convert from standard form to vertex form by completing the square. Let's review those steps. Step 1 is to bracket the x containing terms. Step 2 is to take out the a value, which is right here, and it's negative 1. Notice I'm going to have to write negative 6x after it because negative 1 times negative 6x would give me positive 6x. Our next step in completing the square is to generate a perfect square trinomial inside these brackets. And to do so, what I can do is I can take half of the b value, which is negative 6. That gives me negative 3. And I can square it. So negative 3 times negative 3 is positive 9. Subtract 9 so that I'm not altering the equation in any way, and 432. The next step is I'd like to generate that perfect square trinomial in here by taking that negative 9 out of the brackets. And in doing so, I have to remember that it also gets multiplied by the a value, that it was being multiplied while it was inside the brackets. So let's rewrite what we have left here. Our final step is to factor this perfect square trinomial and to simplify what's outside of the brackets as well. So I can say that revenue equals negative 1 In factoring it, I'm going to take the square root of x squared, which is x, the square root of 9, which is 3. I'm going to decide if it's positive or negative by looking here at the b value. It's going to be negative. And on the outside, I have positive 9 plus 432, which is going to make this a plus 441. Okay. So to put this into context, we have the way that this equation is written, r is like equal to y, so revenue is on this axis. And down here we have the number of 50-cent increases. Okay, and that'll be 1, 2, 3, 4, and so on. And so from here, we can read that the vertex would be 3, 441. So 3 would be here, and up here, 441 would be the maximum daily revenue that I can make. And this is a parabola, and we don't have to draw in the rest of the details, but I just want you to realize that we have found the maximum of it. On the other side, the question says, what could we charge in order to make this revenue happen? So I'm going to go back to the cost per item right here. You'll notice that it was $12 minus a certain number of 50-cent increases, and we decided that, or we calculated that x should be equal to 3. So if we take away 3 50-cent increases, it means that I would charge, in order to make the most money and get the most rentals, $10.50. That would give me my $441 over that time period. Maybe this is a daily thing, maybe this is a weekly thing, doesn't matter. That's what I would have to charge. How many skates do I need to have on hand in order to make that maximum happen? Well, I could do 36 plus 2x, which would be 36 plus 2 times 3, means I'd have to have 42 pairs of skates on hand, charging $10.50 to try and make the most money that I can, which would end up being $441. So it's kind of neat how parabolas can be used to help us solve some financial type questions as well. Our final example has a totally different nature about it. This time we're going to incorporate it into falling objects. So in this scenario, we have a water balloon being thrown from the roof of a school as I'm walking out at the end of the day. No names will be attached to such actions, but we'll have some fun with this. And there's an equation given to us that y equals negative x squared plus 2x plus 3. And we're told that x is the horizontal distance in meters, and that y is the height of the school, also in meters. And the first thing says, let's do a sketch. So let's take this and add a little bit of detail to it. Let's generate a little picture of the school building. We don't know how tall it is, but that's okay. We've got little said person here with water balloon. And so let's put our y-axis here. Height in meters. Actually, sorry, height is in, it is in stories. I misread that. How high it is in stories. 1 story, 2 stories, and so on. My bad. Let's fix that. Okay. Along here we have distance in meters. Okay. And here's a little sketch. Okay, so the water balloon's going to get thrown. I'm going to be down here. Okay, and I'm sure that I'm the intended object or I'm intended target in all of this. Okay, what's the maximum height of the water balloon and how far away from the school does that occur? Well, looks like maybe we're trying to find the vertex when we're told that. So how can we go from standard form into vertex form? You guessed it, we can complete the square. So we have first step is bracketing those x containing terms. I won't bother with the color coding this time. Let's take out the a value of -1. So we're left with x squared minus 2x. Note that, okay, common error that happens sometimes. The two negatives have to multiply to give a positive. Let's generate a perfect square trinomial. We'll be taking half of b, half of -2 would be -1, and squaring it. So we're going to get +1. We have to subtract 1 so that we don't negate the equality that is here. All right, let's take that -1 out. Don't forget it has to be multiplied by the a value that was in front. I've got a little +3 here as well. And then we need to factor that perfect square trinomial. So it's x for the square root of this term here. Square root of 1 would be 1. It's going to end up being negative because b is negative. And out here I have -1 times -1, which is 1 plus 3, gives me 4. So from here I can read the vertex. Okay, the vertex comes out being 1, 4. So that means that the water balloon hits its maximum height of 4 stories 1 meter away from the building. Okay, so gentle toss up. In part C, it says, how many stories high is the school? Well, that's not this value here. This is where the water balloon is. So we want to know at what height was that water balloon thrown from. Now, one of the beautiful things about finding the y-intercept is that it can be done directly from standard form. And the reason it can be done from standard form is that if x is equal to 0, which it is right here at the origin, and we plug in 0 into both x terms, we know that the y-intercept has to be 3. Okay, so the building is 3 stories high. Finally, how far away from the school wall, so how far away from here, is the water balloon when it crashes on the ground? Looks like we're trying to find the x-intercept. Okay, so we've got a couple of options there. The best way might be to go from standard form into intercept form. So could we factor this equation? And the answer is yes. In our factoring unit that preceded this one, we never factored when there was a negative value in front of our highest power of x. So what I'd like to do is I'd like to remove that first. And now you might see what that actually represents. This represents the a value of that parabola, okay? And then we can factor this to give us the x-intercepts. Now, before we do that, you might not be surprised to figure out that if we extend this parabola into the school, there's going to be a negative x-intercept and a positive x-intercept. We are interested, for the purposes of answering this question, in the positive value. So, can we come up with then, in this scenario, two numbers that multiply to give a times c, or 1 times -3, which is -3, and add to give the value of b, which is -2. Well, there aren't many factors of -3. They have to be 1 and 3. And when we add them together, they have to be negative. That means the larger of those two is going to have the negative value. So we can factor this into x plus 1 and x minus 3. To find out what the values of those x-intercepts are, remember that those occur when y is equal to 0. So we can say x plus 1 has to be 0. We can also say that x minus 3 has to be equal to 0 if we want the right side of the equation to be 0 when the left side is equal to 0. Rearranging for x gives x equals -1 and x equals 3. That corresponds nicely with our diagram. A -1 value would be here, and a +3 value would be here. Okay, so therefore, the water balloon crashes on the ground 3 meters away from the school. So there you have it, a few examples of where completing the square is not just an exercise in math, but is actually used to solve some problems. And you also got a little insight to how standard form can be factored to find the x-intercepts for a problem as well. If you have any questions during the practice, don't hesitate to reach out.